Congratulations, you have reached the very last chapter that we're going to be doing. Keep in mind that the first 5 or so that finish for the year get to go to study hall and do not have to take a final. So that's pretty cool. Anyway, in 4.1, we are going to be solving. My smartboard's a little out of whack here. Can I solve what I would call a simple proportion? This is actually a pretty big skill. It's one you'll be using in real life. Some of these other things you've been learning are just for higher levels of math. Like no one's ever going to come up to you on the street and say, hey, you factor this trinomial. But solving proportions is used a lot. It's used for when things are scaled up, when they're scaled down, for money conversions. It's used in construction. It's used in building. It's used in cooking. There are a lot of things in your real life where you're going to have to set up and solve a proportion. So this skill is actually really a good one to have. We're going to focus more on the skill than the word problems, but we will do a few of those as well. So this one's a good one for you. It's not very difficult and it's important, so that's kind of good. A simple proportion, basically, I'm going to not have a variable in it, and we're not going to be solving first. I'm just going to go, first of all, explain what a proportion is. A proportion, here, let's not rewrite the word here. A proportion is actually just two equal ratios. And instead of ratios, I'm going to use the word fractions. So two equal fractions. We say things are in proportional if they've been scaled up or scaled down in the same amount. For example, although 1/2 and 17/34 look incredibly different visually, we say that they're in proportion because each one represents a half. So that is what's called a proportion. The minute I change that 17 to a 16, then it's just a little off and it's not quite in balance or in proportion. So let's put a nice easy fraction like 2/3 up. What would be another one that's proportional to 2/3? And the one that usually pops into people's heads is 4/6. But so is 20 out of 30, or any fraction that reduces to 2/3 is considered in proportion. So let's even throw another one up because I want to prove a point here. Suppose I put 1/4. Well, it's exactly the same. And you could say 2/8, 3/12, 10/40. There's a whole bunch of things that are in proportion. But here's what's in common for every set of proportions that helps you solve them. That, for example, suppose you know that on a map, 1.5 inches actually represents 200 miles of your actual trip. So on the map, there's always a little conversion scale that tells you how much an inch represents. And suppose your little scale at the bottom says that 1.5 inches represents 200 miles. And suppose you're taking a trip and you go to your map and you look at it and your trip is 4.5 inches on the map. Well, then how many miles will you actually be traveling? Well, the thing that allows us to solve for this missing piece is if things are truly in proportion, when you multiply along the diagonals, it's always equal. 1 times 34 is 34, and 2 times 17 is 34. 2 times 6 is 12, 4 times 3 is 12. 1 times 40 is 40, and 10 times 4 is 40. If that is not the case, then they're not proportional. So what that allows us to do is solve for a missing variable, because what we do is we say that if you're truly going to have that map be proportional to the actual traveling distance, then when you multiply on the diagonals, it has to be equal. So 1.5 times x has to equal 200 times 4.5. And I'm going to take out my calculator here and have that do it for me, which is 900. So if I want to figure out what x is, and in this case it represents the miles of my trip, I just need to get rid of that 1.5. Well, the opposite of multiplying by 1.5 is to divide by 1.5. So I take out my calculator and just do 900 divided by 1.5, and I get a 600. What that means is my trip that I've measured on the map, well, I have an actual distance of 600 miles. And that's basically the gist for how we solve what we call simple proportions. So let's just do one or two of those and call it good, because we won't need to do a whole bunch of them. But let's just suppose we had, number one, suppose we have 5 over 16 is equal to 2 over b. Doesn't matter what variable that is. And I'm telling you those are two equal fractions. So what that means is when I multiply on the diagonals, I have to get the exact same thing. So I set up an equation. I say 5 times b is equal to 16 times 2. What that means is 5b is equal to 32. The opposite of multiplying by 5 is to divide by 5. 5 does not go into 32 evenly, and on your first worksheet, you'll be allowed to change that to a decimal. So we're just going to go take 32, divide it by 5, and you'll be rounding to the tenths. And 32 divided by 5 on your calculator, you should take your calculator out and do it, is 6.4. And I've just solved this proportion. It's nice and easy, but it's nice and easy because I said this is what is called a simple proportion. So one more of those, and we'll move on to a little bit more tricky proportion, and then that'll be it. It's kind of a nice, easy little section here. So what I'd like you to do for number 2 is we'll write it down. 7 over 5 is equal to x over 3. If you don't have a calculator, go get one. You'll need one today, and you only need one that does division and multiplication, so you can grab one of the little ones that are on top of the assignment worksheet box. There's a bucket of little black cheap calculators, and those are all you need. You just need to multiply and divide. So go grab a calculator. When you get back, pause this video, or pause it before you go, do this problem, and then replay. So hopefully what you did is you got yourself a calculator, and you did 7 times 3, which is 21, shouldn't have needed a calculator for that, is equal to 5 times x, or 5x. We're trying to solve for x, so we divide both sides by 5. When you take out your calculator and do that, which you'll be allowed to do on this first assignment, you're going to get a 4.2. And hopefully you did that one right. So now what we're going to do is we're going to bump up the difficulty a little bit. And this is where if in elementary school they taught you like you just multiply, divide, that'll mess you up here. So we really need to, when you get the worksheet for this, I'm going to require some work to be shown because I want to see you actually setting those cross products equal to each other and solving. So notice what I've done here. I'm just bumping up the difficulty a tiny little bit. I've put an m-2 on the bottom. But I'm still going to go back to the original definition of a proportion. 2 equal fractions. And if they are equal, then when I multiply the diagonals like I did up here, they're always equal. So I'm going to say 4 times 2 is equal to 8 times m-8. And I have to put that m-8, lock and load it in a set of parentheses. 4 times 2 is 8, and then I've got hippity-hoppity distributive property. 8 times m is 8m. 8 times 8 is 64. Now my goal is to solve this for m. So I need to get rid of those 2 layers. I need to undo a minus 64. So I add it to both sides. And I get 72 is equal to 8 times m. I'm still trying to attack that m and figure out what will cause those 2 fractions to be in balance. I need to divide both sides by 8. And I get my answer of m is equal to 9. Now these are always checkable because you could go right back up here, let's go travel up here, and put this in for m and see if it does make 2 equal fractions. If I did 4 over 9 minus 8, I'd have 4 over 1, which is 4. Is that identical to 8 over 2? And the answer is yes. They are both. The left is 4 and the right is 4 when m is 9. Okay, so the answer is m equals 9. So last one, and then I'm going to have you go grab a worksheet. So the last one we're going to do, example 3, was 5 over r minus 9 is equal to 8 over, oops, my smart board kind of slowed down for a second. I got to wait for it to catch up to me. It's going to be 8 over r plus 5. There it goes. I'm writing too fast for it. And again, I'm going to start these all the exact same way. And I always ask you a question when you come up to me with your notes. And for this one, I'm probably going to say, how do you start these? And it's a rock solid answer. And let's go put that down in our summary. To solve a proportion, I set cross products. And a product is multiplication, so you might even want to say cross multiply, but I set cross products equal. All right, so we multiply on the diagonals basically. Let's write that down. Let's kind of multiply on diagonals. Maybe in middle school, let's also even do this, also known as AKA cross multiply. All right, so let's go do that. I say that 5 times r plus 5, and it needs to get locked and loaded in a set of parentheses, has to be identical to the other diagonal, which is 8 times r minus 9. In order for me to solve that, I need to get that r out of the parentheses, so I do my hippity-hoppity distributive property. I'm going to do 5 times r plus 5 times 5. On the right-hand side, I'm going to do 8 times r minus 8 times 9. Now I've got the variable that needs to be solved for, and it's on both sides. So we just had a little unit not too long ago where we discussed what you need to do to get it on one side. You need to subtract or add it to move it over. And we said move the smaller amount. So let's write that. And what do I mean by that? Well, I've got 8 r's to deal with and 5 r's to deal with. I'm going to get the 5 out of there. And what I'm going to do is subtract 5r to get rid of it. Whatever I do to the left, I also do to the right, and I line it up with its like term. So on the left-hand side, I have 25 left. On the right-hand side, I have 8 r's minus 5 r's. And because they're like terms, I can subtract them. 8 of them minus 5 of them gives me 3 of them. And I still have the minus 72. Now that I've got all my r's kind of lumped together into one term, I can attack it. And to do that, I add 72 because I do the opposite operation. I'm running out of space here. Squeeze it in. And what I get is 97 is equal to 3r. And I need to solve that for r. And to undo 3 times r, I divide. So I'm going to have to go to my calculator and do 97 divided by 3. And we're going to round to the nearest tenths for this assignment. And 97 divided by 3 is 32.3 repeated, or 32 1/3 if you want to leave it as a fraction. I'll take either. So what you're going to do is you're going to go up. You're going to grab the next worksheet. It's pink. And it's worksheet number 1. And you're going to show all the work on it, even if you don't want to, because some of you are going to think this is an easy lesson. But that's just the way it goes. It's like a little puzzle sheet. It's called a definition decoder. So I want you to go grab that, but don't turn your computer off because I'm going to do the last 2 with you. So go get worksheet number 1. It's pink. On the top it says definition decoder. So pause this and then come back, and I'm going to do the last 2. So the last 2, There's a T and an X in their word problems. So I'm going to help you out with those, and then you can do the rest on your own. Argyle, that's kind of a weird name. Argyle can read, here's my son, Argyle, and my other son, Plaid, and these are their two twin sisters, Socks and Shoe. It doesn't sound right. Argyle sounds like clothes. Anywho, Argyle can read, I can hardly say the name. Hopefully you don't have a dad named Argyle and I just ripped on him. Anyway, Argyle can read 7 pages of his book in 5 minutes. That's what we call a ratio. And I'm going to put 7p over 5m so I can keep it straight that I've put the pages on top and the minutes on the bottom. It says how many pages can he read? So I've got to keep that up on the top and I don't know. So I'm going to put an X there. How many pages can he read in 2 hours? Now I can't put hours on the bottom because the bottom is minutes. And 2 hours is 120 minutes. So for me to figure out how many pages he could read at that same rate or if his speed stays in proportion, I just again go 7 times 120, which is 840, is equal to 5 times x. I divide by 5, and I can go to my calculator. Like I said, you should go grab a calculator for this assignment. And I get 840 divided by 5 is 169 pages at that rate. And then what I do is I go to the top and I look for that one. I'm only seeing 168. I wonder if I divided that wrong. Let me try it one more time. I wonder if I hit something wrong on my calculator. 840 divided by 5. Yep, it's 168. I read my calculator wrong. Anyway, so go on the top, and everywhere in that code you see a 168, you're going to put the letter T above it. And when we're done, it'll spell something. All right, I'm going to do one more on that worksheet. So again, you should have gone and picked up the pink worksheet number 1, and I'm doing the last 2 word problems for you. The next one is letter X. There are 1,200 calories in 1 pound of ground beef. And it says how many calories, let's put an X, are in 3 ounces of ground beef. So I can't put a 1 on the bottom because I will want to get that into pounds. So, I mean ounces. 1 pound, hopefully you know that, is 16 dry ounces. So 16 will go on the bottom of here. To solve this, I cross multiply. 1,200 times 3 is 3,600. This has to equal 16 times x. So I take out my calculator and I do 3,600 divided by 16. Hopefully I don't hit a wrong button this time. And I get 225. So everywhere in the code, there's I think 2 or 3 of them that you see a 225 up there. On that little dash, you go put an X. All right, so you go finish up that worksheet. Make sure you're showing all your work, please. And that'll be it for 4.1.